All right, we are looking at the fourth activity in this set of Arduino activities, the RGB nightlight. They called it Circuit 1D. And we're building on what we've done so far with the potentiometer and the photoresistor. And the kind of new component that's been introduced is this LED. And there's more than I'll try to cover all of this. Let's try to do this. And of course, they've got the code down here as well. And I know I said I would do more on how code works in C, so that'll be kind of the next set of videos. But I'll just try to focus on the main kind of components of this and what's going on with the Arduino. So, you know, the RGB LED that they've introduced here is really not that different from what you're used to with the other LED. It's 3 LEDs combined into one. You can think of it that way. It really has, that's the functionality of it, is that you have 3 different pins that you can use to control the component colors. And it's RGB because it has a red, green, and blue kind of LED within it. And of course, you probably know that when you mix light, those are the 3 component colors that you can use to get any other color. So if you mix some red and blue, you get purple, I think. And if you mix different amounts of green and red and blue, you can get whatever colors you need. If you mix almost all, like full brightness of all 3 colors, essentially you'll get a white color. We'll see what it looks like when we plug it into the Tinkercad. There's something else going on here that we'll touch on in a little bit called pulse width modulation. But first, let's just check my LED. And so I've got the LED here. It says it's cathode, common cathode. What does that mean? It means that all 3 of these, LEDs have kind of an input positive pin, if you want to think of it that way, that the current will flow from. So we're going to send current out from a digital pin like we did before. So let's look at this one. So that's hooked up to digital 9. So digital 9, let's imagine it's sending us plus 5 volts, goes through these resistors, which are the 330 ohms, so just the standard current limiting resistor on an LED, into the red pin, and then back out on the cathode, the common cathode, which then goes down into ground. So, but all the other pins do that too. So plus 5 volts through the blue, and then back to the common cathode, back to ground. So we should be able to, test this, and I think it's worth doing. So we should just test this momentarily and see if we can get some blue coming out of this. So I will just drop this over here. In fact, I'm going to drop it only takes a moment, and you might think it's a waste of time until you are stuck with a problem you can't solve. So this should be red, and this should be blue. Okay, it's going to say we had a problem there, but it took a while for it to light up. And that should be green, and everything looks good. So I think we're good. We have the right values of resistors there. That's kind of important too. I mean, they're all the same. You can imagine if we're mixing colors, there's going to be like, a little bit of red versus a lot of red. That's going to make a difference, and those resistors will contribute to that. So that RGB LED is hooked up properly, and I'm going to keep this video simple. I'm not going to spend too much time talking about the coding and what we want to do with the different colors. So actually, I don't have it in here anyway. So, but what I do have is, I have a couple functions. And so I will talk about those. So let's just make sure we have the start of this code kind of organized. what's going on here? Well, I've created 3 variables here that contain the pin numbers for the red, green, and blue pin. Look at what I did here. I created these variables and then I never even used them. I'm not sure what's going on there. I used them down here, so not sure what that's all about. Pin 9 is supposed to be red pin, so just add that there. Blue pin. There's a real need for this because, well, for a couple of reasons. One, you might forget what the pin numbers are, and later on in the code you need to send a output to the green pin, and what number is it you can't remember. You could remember green pin probably before you could remember that it's connected to 11. And what happens if you have to change your pins? That actually does happen sometimes. For instance, sometimes in class we'll have a wire that breaks on us when we actually put it into that pin, so we can't use pin 9 anymore, so we'd have to go back and we'd have to change all the 11s to another number. But when we have variable that we've used, well, then we just change it to whatever we need to. That can become 8 if we want, and that changes it everywhere. So this is a good idea. This is a good idea because it helps us with output. We've talked about that in the last couple of videos. Okay, so these are our global variables. It's the same as processing if you're doing processing right now as well. This is our setup function, same as our setup function and processing. It runs once, okay, so whatever we needed to do, we need to set these pins as output pins. Don't forget, these pins need to be told whether they're an output or an input. And they're output because they're controlling how much voltage goes into this LED. These pins are by default inputs, so we didn't bother doing that. We just use analog read and we can read them. I'm pretty sure, I'm 99% sure we can turn these to outputs if we want, but by default they're set to inputs. Okay, so we do our input, reading our different things, read stuff, at least it's a comment, and then we outputted it, which was really useful, but I'll just kind of turn that off for now. And you know what, I'm not even going to use this for now either. I'd like to just I'd like to just make that go away. So I do have some functions down here, so let's look at this function for a moment. It's called off. The function is called off. And the syntax for a function is that you have the name, and that's the name. You have any parameters that are coming in. So this is a nice simple function, it has no parameters coming in. And it doesn't send any parameters back. So that's why we said void here. So when I type this function, I type void off, parameters nothing, and code, it's going to be something. I would encourage you to write it like that and then start your code in here. Okay. And inside of this function we've got 3 statements. We're going to set these analog pins to 0. We're going to turn them off. So this is turning the LED, the RGB LED off. That's all it does. And you can make use of this function by using it in your code elsewhere. So for instance, if we wanted to use our code, like if we wanted the loop, every time the loop runs we do these reads. I'm just going to put a little delay in there as well because that is kind of a good idea. And then we turn off the LED. This is not going to be very exciting. That does not do a whole lot. Let's get like some white happening here. And I said we mix maximum values. Might be wondering what the heck is analog rate in the first place. But let's just focus on the functions. The function name here is white, and I'm setting this thing to 255. And you'll notice I get this white color. It'd be like a bright white light in real life, but and you can see I had an orange one down here as well. Exact same setup, just different values here. So what's that one look like? Guessing it's kind of orange. Hope that's orange. And yeah, so And all I'm doing here to kind of test all these different functions is I'm just changing the name of the code that we're running. So, you know, don't forget our LED flash program. You know, we could kind of do something like that. Orange, white, off. Delay of 1 second in between. So we should see orange, white, off. Orange, white, off. So we're just cycling through because the loop function runs repeatedly, right? After it completes, it immediately goes back and tries to run it again. It does some other stuff, like reads these pins and stuff, but for our purposes, we just imagine it running again. So functions can be really useful way to organize your code. You know, you can keep your main loop organized here. This is a smaller loop here. Imagine if we had to put in all the 3 lines each time. We get one, you know, and imagine these were even longer. We would, you know, save a lot of code from messing up our loop function. And, you know, this is descriptive, so we know what this does. If we saw a bunch of analog writes with these values, we may not even know. So when we look at this, we immediately know that we're trying to set that LED to orange. So these are all really important benefits. They might seem simple, or they might seem kind of like, you know, I don't need to do that, but in fact, you really do need to do that, because as soon as your code starts to get, you know, more than so many lines, whatever it is, 40 lines, 30, whatever, it gets confusing. So students, I find, do struggle with functions, but the first way I think to think of a function is this way. It's just a little mini program that we have sitting down here now, and then we just get to call the name of it, and it will run for us. Okay, so that is something you really need to do, especially on this one, is use some functions. Even if they're all virtually the same except for these values, it's a great starting point for writing some functions. All right, so last thing I'll talk about is what is analog write. So back to the reference manual, and I'm going to go back. So we were talking about analog read before, but now we're talking about analog write. And description: writes an analog value PWM wave to a pin. Can be used to light an LED at various brightnesses. Okay, so you're going to have to read up on this. You definitely want to read what this PWM wave is. But we'll just look at this graph for a moment. Analog write means that we can put a number, it said, from 0 to 255. Analog write 0, analog write 255. And there's some intermediate values here. If we write a 0, our pin that remember, it's a digital pin. It can only be sending, you know, we might not have talked about this. All you can send out of a digital pin is 0 volts or 5 volts. That's why it's digital. It has only 2 options. It operates binary, in a binary manner, in a digital manner, all off, completely off, or completely on. So, you know, that seems kind of limiting. Like, what if we need to, you know, in this case, we're asking, we want to be able to mix different colors. What if we need, you know, halfway red? What if we need a little bit of red, but not the full blast of red and not totally off? Well, this is the solution, because when we analog write values in between, so this one is fully off, 0, and 255 is fully on, 5 volts. But when we write a value in between, like 127, look what we get. We get 5 volts for kind of half of the time. So this is time going to the right, and this is voltage on the y-axis. So half of the time it's on, and half of the time it's off. And this amount of time here is very short. I don't think it's telling us what it's saying. So it's saying maybe 2 milliseconds. So 2 milliseconds on, 2 milliseconds off, 2 milliseconds on, 2 milliseconds off. And our eyes, instead of perceiving this as flashing very rapidly, perceive this as brightness. So we see this as kind of half on. And this is really useful because for something like this, we can see something that is half on, like in orange. We have red pretty much half on, and oops. So orange, we have red about half on, and green like maybe a quarter on, a fifth on. And you can see we get, a color of, let's turn green off totally. Let's just see what we get on the red. And if we measure that voltage, and that's pretty much fully on, it's hard to tell on the simulator. It would be far more evident in real life. It's really hard to see that that's supposed to be kind of like a little bit red, but not very red. It's pretty hard, I think, for them to kind of simulate that. But that's a pretty faint red. You can see what's happening there. Versus like pretty much fully on, which looks like that. Okay, so what's really supposed to happen in real life is that we get this fast oscillating square wave that is proportional to how bright it's supposed to be, and lets us control. Now we can mix some red, some green, some orange, and get some colors that look, kind of like what they're supposed to be. RGB color picker, you can find your values, you can use processing. This is great. So so I don't know what color I'm doing here, but I have something that has like a good chunk of red, a lot of green, and not much blue. I can pull that color out, say that color's whatever I need, and I can pop those colors down into my 179, 242, and 41. So, does that look like this color here? Should be pretty close. So we can kind of match that color up. So just Google RGB color picker to kind of get your color set up. So, and this is, I think this is kind of the main kind of learning for this one, beyond the coding part, but I will try to follow up with some more learning to code in Arduino C, though I think, we really did talk about functions today. We've talked a little bit about other stuff. Hopefully you're starting to get a feel for this.